So in the last class we discussed this type of differential equation, and based on the different values of m we got different type of solutions. Okay, so one by one we'll see. For that, first of all, what we had in our last lecture, that auxiliary equation. First let me repeat that auxiliary equation. What you got, m square plus pm plus q is equals to 0. Okay, so now see, this is nothing but a quadratic equation in m. Okay, so you'll be getting two values of m. Suppose those values are m1 and m2. Okay, now see, if m1 and m2, they are real and distinct, that means m1 not equals to m2. So in that case, what you will get, in this case you'll be getting the solution as c1 e power m1x plus c2 e power m2x. Okay, this will be the solution. So in that case, what you have, suppose y1x is equals to e power m1x and y2x is nothing but e power m2x, and this will be the general solution. All right, now if m1 and m2 are real and identical, so in this, what you have, see, m1 and m2, they are same. m1 is equals to m2, suppose we say as m. So the general solution, it is given by y is equals to c1 plus c2x bracket close, here e power mx. Okay, this will be the general solution. Now from here, y1x is e power mx and y2x is x e power mx. Alright, so this is the general solution. Now another case what we have is m1 and m2 are complex, and you know that m1 and m2 are complex means they will come as a conjugate pair. So if m1 is a plus ib form, then m2 has to be a minus ib form. So in this case, y is equals to e power ax c1 cos bx plus c2 sin bx will be the general solution. And here also, y1 is e power ax cos bx and y2 e power ax sin bx. Now here, see, this is a second order equation. So here you have y1 y2, here also y1 and y2, here also y1 y2. Now this y1 and y2, they are linearly independent. So in this case, what you need to have, it is a term called Wronskian. So you'll be checking the Wronskian so that this y1 and y2, they are linearly independent or not. This thing you can decide. So what is Wronskian? So let me define this Wronskian. So Wronskian of two functions, suppose Wronskian of fx and gx I want to find. So that is denoted by w of f and g, that is f g f dash g dash. This is the Wronskian value for two functions. So if this Wronskian value it is 0, then immediately f and g are linearly dependent. If non-zero, then f and g are linearly independent. See, here y1 and y2 you got. For example, this first case, if you take y1 and y2, if you just find the Wronskian, you will see that Wronskian value, it is non-zero. So immediately you can claim this y1 and y2, they are linearly independent. So in this case, the linear span, okay, of this y1 and y2 will constitute this general solution as y. Okay, where the c1 and c2 are arbitrary constants. So this is the basic idea. Now see, here I can give you one or two questions so that you can check these functions are linearly independent or not. So for that, let us take this question. Check the Wronskian check the Wronskian of fx is equals to x and gx is equals to x e power x, and from the Wronskian you can conclude whether these functions are dependent or not. So immediately w of f and g you can find by putting x e power x. Here the derivative of x, that is 1. Here derivative of this x e power x, if you do, you'll find x plus 1 e power x. So perform the calculation, you'll be getting x square plus x e power x minus x e power x. So x square e power x. So this is non-zero except at x equals to 0. So immediately we claim that f and g functions are linearly independent except at x equals to 0. Okay, this is the conclusion. So that's why this Wronskian term, it is important, and in subsequent courses, for example the linear algebra course, you'll find a vital application of this as well. Okay, now see, there are few results related to this Wronskian. So one of the important result, as a note you can consider this, one of the important result is, suppose y1 x and y2 x are any two solutions of this main equation. This was, suppose, equation number star. Okay, it is solution of equation star on the interval AB. Okay, now the result, it is related to Wronskian, that is Wronskian of y1 and y2 is either identically zero or never zero throughout this entire domain. Okay, that is on AB. Okay, either identically zero or never zero on this interval. Okay, that means w of y1 and y2, this is equals to 0 for all x belongs to AB, or y1 y2 not equals to 0 for all x belongs to AB. That means in this interval, at any point, if you are able to find this Wronskian 0, that means throughout this entire domain it will be 0. If non-zero means throughout this entire domain it is non-zero. Okay, so this is one of the important result. There is no such direct application of this result currently, but in the subsequent courses you will find it, particularly linear algebra, you will get the direct application. Now see, when we are considering this second order linear differential equation with constant coefficients, so the solution technique, there are many techniques. For example, first, but we had that trial method with the exponential function. Okay, then what you have, the method of undetermined coefficient and variation parameter, method of variation parameter. So for the first case, trial method with e power mx, we'll do the trial by e power mx. Okay, so let's start with the e power mx. Here see, So in this case, these three results are very important. So if real and distinct m values, so you have this one as the general solution. If real and identical, then this one is the general solution. If complex number, then this one is the general solution. Okay, so we're going to the next slide. So take this first question. Find general solution of y double dash plus y is equals to 0. Solution. See, immediately this equation you can write in terms of the operator. So y double dash plus y is equals to 0. That can be written as y, this d square plus 1, y is equals to 0, where this d, it stands for this operator, differential operator. So immediately the auxiliary equation you can write, in place of d you can write m. So m square plus 1 is equals to 0. This is the direct method. Or if you want, you can take the trial with y is equals to e power mx, then substitute y dash, y double dash, all these things here, and ultimately you will get this equation, which is nothing but equation in m, and quadratic equation as well. So if you solve this one, m is equals to plus minus I you will be getting. So initially you can consider this I and minus I like this way, so that you can tally with the basic formula 0 plus I and 0 minus I. Now here let's see the solution, that is y x, it is given by e power ax, that is 0 x, here a is 0, c1 cos bx, so what is b here, 1, so cos x, plus c2 sin x. So what you have, see, c1 cos x plus c2 sin x, this will be the solution. Yx is equals to this. This is the general solution, where c1 and c2 are arbitrary constants. Okay, simple question. Similar type of another question you can take. Find general solution of y double dash minus y is equals to 0. So in this case, see, solution, to try these questions, so the auxiliary equation you can write d square minus 1 is equals to 0, this one. Okay, this is the operator form. So the auxiliary equation AE, it is m square minus 1 is equals to 0. So m is equals to plus minus 1. So real and distinct. So in this case, yx, it is nothing but c1 e power x plus c2 e power minus x. So in this case, what you have, see, this is your y1 x and this is your y2 x. These are the independent solutions. Similarly here, this is y1 x and this is y2 x. Now linear combination of this y1 and y2, it is constituting the general solution. So general solution is this one. Okay, like this we can solve this type of questions. Now next problem you can take. Suppose find general solution of y triple dash plus y dash is equals to 0. This is a homework question, you can try this question. So in this case, the operator solution, I am giving you the hints. The operator, it is d cube plus d y is equals to 0. Okay, this is the operator form. So immediately the auxiliary equation will be m cube plus m is equals to 0. So if you solve this one, you will be getting m square plus 1 is equals to 0, that is m is equals to 0 and plus minus plus minus I. Okay, so for 0 what you will have, suppose y1 x, it is e power 0x, this is real, and from here the complex part, that is y2 e power 0x, e power 0x cos x, that is cos x, and y3, which is e power 0x sin x, so sin x. Now combination of y1, y2 and y3 will give you the general solution. General solution, it is given by e power 0x means 1, so in that case yx, it is c1 y1x plus c2 y2x plus c3 y3x, and ultimately you will have c1 plus c2 cos x plus c3 sin x, that is yx. So you can see this is a mixed type of equation where one part it constitute the real, okay, real value, another part it constitute the imaginary part. Okay, so likewise we can solve this type of question. Now another important thing is, so far the homogeneous type of equation we considered. Okay, here you can see there is a right hand part, it is 0 for this equation and previous equations as well. Okay, whatever equation we considered, these equations were homogeneous equation. Now suppose it is non-homogeneous. Okay, so in that case, in the general form, first you can write down this general form. Suppose this nth order dn dxn plus k1 dn minus 1 y dxn minus 1 plus k2 dn minus 2 y dxn minus 2 plus so on up to kn y is equals to 0, means you have the homogeneous. Now I am writing here fx, which is nothing but function of x. So in that case, what will be the solution? So if it is 0, that means if you consider here 0, so immediately homogeneous equation you will get. Okay, nth order homogeneous differential equation you will get if you put here 0. Now, so in this case, if y1 y2 up to how many solutions will be there, independent solutions, n number of independent solutions you will get. If y1 y2 up to yn are n independent solutions of the corresponding homogeneous equation, then c1 y1 plus c2 y2 plus cn yn, this will be the complete solution for that corresponding homogeneous equation. Okay, but we are dealing with non-homogeneous equation. So c1 y1 plus c2 y2 plus cn yn, suppose we call it as u, is complete solution for that homogeneous equation. Okay, that will be contributed from that homogeneous equation part. Okay, now here what we have, fx is nothing but function of x. So due to the presence of this non-homogeneous condition, see, if y is equals to v is a particular solution, this is a particular solution of, suppose this equation, it is suppose double star, okay, of double star, then of double star, then as a whole this is a particular solution and this is the solution for that homogeneous equation. Okay, Okay, so as a whole, y is equals to u plus v. Then as a whole, y is equals to u plus v. This is the complete solution. This is the complete solution for this entire equation, okay. One part it is contributed from that homogeneous, and another part it is contributed from the non-homogeneous section. Okay, so this u, it is called as complementary function. This term, it is called as complementary function, or in short CF. And this v, this is known as particular integral. Okay, that is pi. So whenever we have this non-homogeneous type of equation with constant coefficients, so immediately we'll go for this complementary function and the particular integral investigation. Okay, so complementary function we need to find from that corresponding homogeneous equation, okay, or whatever method we learned so far. Okay, create auxiliary function, then from there, based on the values of m, you will get the complementary function part. And particular integral, we have separate technique, we'll see. Okay, so you can take one or two question. So for homogeneous, see, let me take one question. Was solve this equation d2y plus 5dy dx plus 6y is equals to 0, given y0 is equals to 0 and dy dx at is equals to 0, it is 15. Okay, this is given in the question. See, whenever these type of conditions are given, already we stated in our first class that regarding the initial value problem. Okay, so the initial values are prescribed so that you can determine the arbitrary constants values. Okay, so these are given in this question. In this case, solution, first you need to write the operator form. D plus 6 y is equals to 0, where d is d dx. Okay, now the auxiliary equation, you can write m square plus 5m plus 6 is equals to 0. So here m plus 3 is 2. So the values are minus 3 minus 2. So complementary function, see, CF. For this question, see, this is a homogeneous equation. So particular integral, it is 0. Homogeneous case, basically particular integral, that is 0. Now see, CF, it is given by C1 e power minus 3x plus C2 e power minus 2x. Okay, so in this case, the general solution, it is given by yx is equals to CF plus pi, that is e1 e power minus x minus 3x plus c2 e power minus 2x, that is yx. Okay, now here you can apply these conditions, and before that just find out dy dx, because this condition will be required. Minus 3 c1 e power minus 3x minus 2 c2 e power minus 2x. Now apply the conditions. It is y0 is equals to 0, that is c1 plus c2 is equals to 0, and dy dx at 0, it is 15. So it will be minus 3 c1 minus 2 c2, that is 15. So from here you can write c2 is equals to minus c1. So here minus 3 c1 plus 2 c2, c1 is equals to 15. So c1 is equals to minus 15 and c2 is equals to 15. So all together you can get the particular solution. So the particular solution, what will be that particular solution? Just back substitute. So yx is equals to c1 means minus 15 e power minus 3x plus 15 e power minus 2x. This will be the final solution. Now this type of question you should practice. Now see, to find this particular integral, one very standard method we use, that is variation of parameter method. But before that, we can solve one or two more questions based on this idea. I can give you a few questions, just try. So solve this question. D cube plus d square plus 4d plus 4 y is equals to 0. This equation, okay, cubic equation. Now see, we can start this variation parameter, and by that time you can practice few questions. PDFs are already shared in VIT-AP, so you can practice those questions, and if you find any difficulty you can obviously discuss. Now we are starting this method of variation parameter, method of variation of parameter method of variation of parameter. All right, see, here you will have this type of equation: y double dash plus p y dash plus, suppose, q into y, that is fx, okay, for the case of second order equation. So here you have this one where fx, it is the function of x, okay, p q fx is a function of x. So for the time being we are sticking to p and q as constant, okay, for the time being. So p and q, if they are constant, then what you have? Second order differential equation, non-homogeneous obviously, with constant coefficients. So here the general solution, if you consider the general solution, that is CF complementary function plus particular integral, okay. So CF, it is nothing but C1 y1 x plus C2 y2 x, and particular integral, it is given by, as per this method, variation of parameter method, this one given by minus y1 integral y2 fx divided by w dx plus y2 integral y1 fx divided by w dx, where this w stands for Wronskian. So for the case of two solutions, what you have, this Wronskian, y1 y2 y1 dash y2 dash, okay, this is what you have. All right, so basically for your syllabus we are sticking to this notion that p and q are going to be constant, and here you have second order differential equation, and in this case CF you can determine by applying the previous method, and particular integral you can determine by applying this one. Now you can take one simple question. Solve d2 plus 1 cosec x plus 1 y is equals to cosec x. So here you can identify this is a homogeneous equation, and already it is given in terms of operator t, okay. So solution, you can see auxiliary equation, you can directly write auxiliary equation, that is given by m square plus 1 is equals to 0. So m will be plus minus I, okay. So CF it is given by C1 cos x plus C2 sin x, taking this one as homogeneous equation, already we have solved this type of question. Okay, you can refer to the previous slides. Now see, this is the CF. So from this CF you can identify this is your y1 x and this is your y2 x. Okay, so what is the next requirement? Next requirement is W, Wronskian. So immediately you can calculate Wronskian here, that is cos x sin x, here minus sin x, here you have cos x. So if you do the calculation you will get 1. Okay, so the particular integral, it is given by minus y1 means cos x, here integral y2 means sin x, here fx means cosec x, so you can write cosec x divided by Wronskian value 1 dx plus here you have sin x integral, but you have y1 means cos x into cosec x by 1 dx. Okay, so here what will be the value? See, minus cos x, here integration dx plus sin x integration, see here cos x by sin x dx. So immediately what you will have, minus x cos x plus here sin x into logarithm log sin x. Now this is the particular integral you have, this is the particular integral, and this is the complementary function. So finally you can write down the general solution. So the general solution is given by y is equals to c1 cos x plus c2 sin x plus sin x, that particular integral part, log sin x minus x cos x. So this is the entire solution you have. This is variation of parameter method. Using method of variation parameter, you can solve this question as well. Next problem can take d2y dx2 plus 4y is equals to tan 2x. Can solve this question. This is homework question. Can try. Okay. So up to that, if you have any doubt, you can put here. So far what we discussed, we had that homogeneous equation with constant coefficient. So based on the different values of m, we got 3 different scenario, and then we studied Wronskian and few basic questions related to that. After that, trial method by e power mx, and we can determine the solution. And after that, method of variation parameter, just now we started and we completed. See, this type of questions require practice, otherwise you will stuck at the calculation point. Okay, that's why just practice this type of question, and whatever the integration formula, those things you should keep in your mind. That is the basic requirement. Okay, so in next class we'll start method of undetermined coefficient, and also we'll handle few questions if you have. By that time you should practice. Okay, and one question, one of your friends, they have asked this question, so let me clarify this question. See, it was solution for this question, solution for x square y dy x cube plus y cube dx. This question, one of your friend, I think 2 students, they have asked this question. I don't know from where you got this question, but here few mistake you have. Okay, up to a certain level you can do. After that numerical technique it is required, although it is homogeneous type of equation. See, but you can write dy dx is equals to x cube plus y cube square y, this one. So immediately you will substitute y is equals to vx, substitute y is equals to vx, so that dy dx you can write vx dv dx, substitute here, so you will get v plus x dv dx. So from here x cube plus v cube x cube you can write, here x square vx you can write. So after doing the simplification you will get this v. So from here x dv dx is equals to 1 plus v cube minus v square by v you are getting. So from here v dv 1 plus v cube minus v square, here you have dx by x. Up to this all of you can do. Okay, so after that you need to do this integration. Now while doing this integration, this particularly this part, see, integral of, you can make this one equation number 1, integral of v dv 1 plus v cube minus v square, this one you need to handle. So v by 1 plus v cube minus v square, you can solve this one if partial decomposition it is possible. Okay, so partial decomposition, for that factorization of this term, it is required. This term, can you factorize this one? So factorize this one. If you are able to factorize this, then partial decomposition. Afterwards you need to apply partial decomposition. So if you have this type of integral involved in these questions, then see, take help of partial decomposition method. That means what I am trying to say, if this one can be written as, that is 1 plus v cube minus v square, if this one, suppose it can be written as suppose v minus alpha multiplied with suppose this is quite this is cubic equation, so v square plus beta v plus gamma, suppose. Okay, suppose this can be written as this, that is, you are basically decomposing this one. Or if it is written as v minus alpha, v minus beta, v minus gamma, suppose. Okay, if it is possible. So in that case, this entire term, it can be written as a by alpha, v minus, this technique already you learned in 12th standard. So v minus alpha plus b by v minus beta plus c by v minus gamma. Okay, this is partial decomposition. Now see, after that what you need to do, see, let me erase this part. After that, see, v is equals to, I'm not going for the calculation, I'm just giving you the outline how to proceed for this type of question. So v is equals to a v minus beta v minus gamma plus b v minus alpha v minus gamma plus c v minus alpha v minus beta. Now for v is equals to alpha, you just put v is equals to alpha in this identity. Okay, so immediately you will get the value for a. Okay, you'll get the value for a. If you put v is equals to beta, you'll get the value for b. Just see, this part, this first part and second part will vanish, you will only have the second part. So from here you will get b value. V is equals to gamma, if you put, immediately you will get c value. Now once these values are done, then immediately you can back substitute here in this equation and you will get this entire form. which you can directly integrate. Okay, which you can directly integrate and will get a simplified version. Okay. So this is the process of partial decomposition, and this is useful while solving this type of question. But here in this question, this polynomial, that is b cube minus b square plus 1 itself, it is tough to factorize. Okay, so in this case you'll stuck, and anyhow if you can find the factorized form, and then immediately this partial decomposition method will work. Okay, see, if you are able to find this form, this last form, then this is the methodology. If this form you are getting, suppose this second part, it is not getting factorized, okay, quadratic form, so in this case what you need to take, see, v by 1 plus v cube minus v square, a by v minus alpha plus, here see, v b plus c divided by that form, v square plus beta v plus gamma. Okay, this form you need to take. Again the same process you will have. That means you will take this upper term, that is v is equals to a v square plus b v plus gamma plus v p plus c v minus alpha. Then here you will compare both sides, the coefficient of v square, coefficient of v, and the constant term. You will compare and you will get three equations. From there you need to find out a b c value, back substitute, and you will get the answer. So this is the method I am giving you. But for this question, 1 plus v cube minus v square, you need to factorize it. If you are able to get, then okay, otherwise just write down this methodology, that is sufficient. If you are getting this type of question, just write down this methodology. If you are unable to factorize this, then you will get certain amount. Okay, so if you have any doubt, you can obviously ask, or otherwise we can end here.